Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 1 to 4 binary tree maximum path sum. Before jumping into the solution, I would highly recommend you should read the problem statement and give at least 15 to 30 minutes before seeing this solution in order to understand my intuitions and what I am trying to convey, because if you have done your homework, then it would be more easy to fill those gaps. So let's get into it. What problem is asking? You just need to return the path sum, and that should be the maximum. What path sum is? If we start from 9 to go minus 10 and to go 20, and then from there we go to 7, how much we are getting is minus 1. It's 19 plus 7, and it's 26. I hope so. And if we go here, how much we would be getting is 15 plus 19. 19 plus 15, it would be 34. And if we make a path like this, 15, 20 and 7, how much we would be getting is, it's 35 plus 7, 5, 12, and it's 42. That is our maximum, so that you have to return. I hope it made sense. But how to approach this? You could have done up till here, but how to approach this? While doing this, when we are checking something that this would work or this would work or this would work, and also we are on tree, binary tree. It's binary tree, na? Let me see. Yeah, binary tree. There are two things using which you can traverse a tree. It is a BFS and it's a DFS. But what to use? Here we are doing if it is good, if it is not good. When this thing happens, it is very difficult to handle in iteration. So BFS rules out. DFS is the way to go. So how we are going to apply DFS? Let's see. Let me make this. My explanation would be very different than others, but I am conveying what I see, what I preach, not preach, how my brain works. I'm trying to convey that to you. So we go in the depth. First we go in the depth, and we would be using in order types, not in order, pre-order, post-order traversal. Why? You will get it. And post-order traversal is left, right, root. So left, we go to left, we go to right, nothing. We would return 0 0 over here, and this. Here things get interesting. How things are calculated over here. The sum. When calculating the sum, you have two choices. What are those choices? One is this type of choice. If you are having this subtree, add these three. How you can get these three? Sum is using its left, its right, and its root. So LH plus RH, right hand side, left hand side, plus its root value. And the other thing, how can you get, not how, what can you get, is take the maximum of these two, whichever it is, plus this. Why we are doing this, not doing this, considering this case, because this closes the paths. This path won't lead to any other. If we have tree like over here, it's just cut off all the roots. But if you use this, you can go up, you can go up, you have still the option. It's like no option. You are still options are left to explore. These two cases we would be taking. So first case is like this, and other case would be like this: root val plus max of LH comma RH. That's it. And what we would be doing is, if let me, why is it not scrolling down? Let me write. Now it will scroll. What the heck? Let's see, where were we? We were at the 9. We get 0 0, and let me write the pseudo code for it. What we are getting: sum max is equals to max sum comma LH plus RH plus root val, and we would be returning LH RH max plus root val. Now the confusion will arise. You said before that we would be taking these two, but what I'm trying to convey is, this is the closed off root. So recursion in recursion, this would happen only one time. This calculation, this one will transfer it to the ancestor. This calculation will not be transferred to our ancestor because we just closed our option over here. So we would be just considering that subtree, and that you can consider is at subtree, and this is one branch. This branch has option because while calculating depth, also max depth, what you do, it doesn't mean that it should be going from this or going from root. It doesn't mean you can have more height using this also. So it doesn't mean that you have to go from the root. Okay, or it can, that case happen over here also. If we have something like this, what we would be taking is this branch. If we try to took this only, then we would have less height. But if we use this, we would be able to survive and see the next day. That what we are doing over here. We are taking these two branches and see if which one is max, take the max plus this, and see the future what could happen. So that's what we are doing. These two lines are just all the things that you need to understand. These two lines are the main thing. So at 9, let's copy this. Let's zoom it. At 9, these two lines will be executed. From left you got 0, from right you got 0. If we have this sum max, we would take its int min for obvious reason, not gonna explain. 0 plus 0 plus 9, max sum is 9, and what we would be returning is 9 because the max of both of them is 0 and plus 9. So here it is 9 again. Now it's time for the right. 20. Then we go deep. This again we would be getting 15. Not gonna again show it to you how it's done. 15. From here we get 7 and now it's the place where thing happen. Also see that this, how to return this 15, how this 15 was possible, because of this line. Now it would make sense, and in order to make more sense, I would highly recommend you use pen and paper on your own. So this, we return 7. What now? From left we got 15, from right we got 7, and root is 20. Now up till now we were having 9. Now what we were having, now we are having is 47, and what we would be returning from this is whichever is greatest. 15 is greatest, 20, 35 would be returned. Now at 10, what would be happening is, we got from left 19, not 19, 9, and from right we got 35. In himself he is minus 10, minus 1, 34. That's it. We would be returning, what we would be returning, 35 minus 10, it's 25. But this is not our answer. We would be saving our answer in a global variable beforehand, so that you can have the correct answer. 47 is the correct answer. And where was the test case? As you can see, 47 or 42 did we got? I just miscalculated. 35 plus 7, it's 42. My bad. 42 it is. Yeah, we are getting 42. I hope you got it. What is the algo? I just did. Algo would be this. Depth. How depth is done? Go to left call, right call, then what we would be doing is sum max. Sum max is like, you would be getting something in left call, in right call, some base case. Base case is very trivial. If we point to null, return 0, because there is nothing. What we would be doing is comparing this and this, LH plus RH plus, what was it, root value. And for returning, what we would be doing is this, the max of LH comma RH plus root value. Why? Because it makes our option alive. This just kills it, and see, no future. But in our test case, this led to the maximum path sum. So you have to consider both the option. Do you want to see the future, or do you just want to get the result now? So I already iterated that over the test case, so nothing more to explain. Let's see the code. Code is very basic calls, and this is the base case, the left call, the right call, and we are calculating the option that doesn't lead to any future. And what we would be returning is the one that leads to some future, that lives to fight another day. That's it. That's how we getting it. And I would highly recommend you should use pen and paper to understand it more. Yeah, it is running. It is running quite slow. Previously it was running 19, whatever it is. Our code is working. I hope I was able to make you understand, build the intuition, and you guys are awesome. See you in the next one, and you have to do what you have to do. So keep grinding, and see you in the next one. Bye bye.